Good evening, class, and welcome to our performance management class this evening. Today, we'll be taking a topic called linear programming model. Now, this is a subtopic from the marginal costing based decision. So, what is linear programming model? You will know that linear is straight line. So what has straight line has to do with a programming model. When you see programming, don't be scared. You're not going to be learning programming language like Python, SQL, and all that. No, but you will be solving using a programming technique. Now, for those of us who are doing Excel, the function that calls for linear programming is in your what if analysis, which is scenario based, and you'll see something like solver, and it uses linear programming model. So you are trying to solve a kind of um, assignment, or you trying to solve a transportation problem or so. So what is linear programming? What are the techniques? At the end of the lecture, you'll be able to draw up an optimal production plan where there are more than one limiting factor. So we learned in limiting factor that there is, we learned when there is only one limiting factor and there are maybe two or more products that use that one limiting factor. We learned that before. But sometimes life does not happen that you have only one limiting factor. You might have more than one limiting factor affecting your production at the same time. And so you will not be able to use the limiting factor solution to solve this. You will now use something called the linear programming model. Now, there are two methods that you can use. We'll be learning the graphical method and the simplex method. Then you'll be seeing something called shadow price. Now, I must tell you that for the past 10 years, ICANN has perhaps set linear programming problem twice. And so this is not much an area that I can test that much, but that doesn't mean you shouldn't know it, because I can put that in your syllabus that you should know it. And so anytime they could test it. So just know that if you're looking for past questions on linear programming model, you won't see much. And we are going to be taking one of that past question and we are going to expand it. So I want you to pay more than the usual attention to this topic and let it also, how will I say it? Let your learning curve also be felt in this linear programming technique. In a production facility, there may be more than one scarce resource, as I mentioned, and when that occurs, you cannot just use ranking of your products and now determine the optimal production based on the ranking. No, you must use something called the linear programming model to determine which is the best outcome. Now, for a company, the best outcome could be based on their objective. Most of the objective of a company is to maximize profits. And one way to maximize profit, as we've learned, is to maximize your contribution. So maximizing your contribution will make you to have enough contribution to cover your fixed costs. And when your fixed cost has been covered, any extra contribution becomes a profit. So as you are maximizing contribution, you are maximizing your profit. Now, linear programming model involves either maximizing a profit or minimizing costs in a linear function. When we say a linear function, it means straight line. It means the constraints are linearly related. It means they are straight line in their relationship. We're going to be seeing that. Now, both the constraint and the best outcome are represented as straight line relationship. That's why it is called linear programming. What constitutes the best outcome depends on their objective. The equated construct the equation is constructed to represent the best outcome to achieve the objective. Now look at the overall approach. If you are given a linear programming problem, how would you know? They will ask you to find the optimal solution. Now, when you see find optimal solution or optimal production, two things should come to your mind. It's either it is a limiting factor problem or it is a linear programming problem. Now, how will you know which is which? You have to check how many of the constraints are available there. How many constraints do we have? I've told us how to get a constraint. A constraint is you are told this is what is required to do this job. 500 units or 500 hours is required to do this job, right? But you have available manpower, 400. That means you have a constraint of 100. Now, if that's the only constraint that you have, you will use the limiting factor problem solution to solve that. But assuming you now have this labor constraint, then you check your material. They're asking you that you need material X. You require 1,000 units and you have available, maximum available is 800. Then there is a constraint. It's not all about relevant costing, no. It's all about constraint, theory of constraint. Now, how will you solve this problem? So once you have identified that there are more than one constraint, you know you need a linear programming. So you need to define your variables. What do we mean by defining your variables? It means that you will have to bring the real life world into book and paper and biro. In paper and biro or paper and pen, you will define your variables. For example, you are doing bread and you are doing cake, and you have manpower constraint, you have material constraint. You will need to define your bread, let's say your bread is X and your cake is Y. You have defined your constraint with X and Y. Second, you need to formulate the objective function. The objective function could be to maximize contribution. Then you need to formulate the constraints. After that, you will need to solve the problem. So the first part of the approach is to formulate the problem by defining variables, objective functions, and the constraint. Then the second part is to solve the problem. You can use the graphical approach to solve the problem, identify the feasible region, then identify the value of X and Y within that feasible region that will give you the optimal value of the objective function. All right, so we've talked about this. I wouldn't want to talk too much about that. Let's solve a question. Now, instead of solving this particular question, because the solution is here, I will also want you to, let's take the I can past question and we'll see what we can do about it. This is November 2017, question number 5. November 2017, question number 5. We will be using this particular question alone to demonstrate linear programming problems. Now, let's read it. SKD Holdings makes two products. So for a linear programming model, it must have, for any limiting factor problem, either linear or limiting factor, the products must be more than one. So they makes two products, donuts and meat pie. Now, their contribution margins. Now, because they mention contribution margin here, you'll know that contribution needs to be maximized. So you need to know what is the objective of the company. The mention of contribution or profit means that they want to maximize their contribution. Now, the contribution margin are 100 naira and 115 naira per unit respectively. So it means that one donut, you make a contribution. So it means we are not interested in the selling price. We are not interested in the variable cost. It could be that the selling price is 250 and the variable cost is 150. What it gives you is a contribution margin of 100. That is what we are after. We don't care about the selling price now. We care about the contribution. Now, meat pie is contributing 115 naira per unit. Now, the production passes through 3 machines. So it means that these are the things that could likely cause a limiting factor. Machine, and we have machine hours. So we have M1, M2, and M3. These are the names of the machines, whose available hours are 800, 600, and 720 hours respectively. So it means that these machines cannot go beyond that hours. Okay? Now, donuts requires 8 hours. That means to make one donut, you requires 8 hours using it in machine A, 10 hours using it in machine 2. That one is machine 1. So this is 10 hours in machine 2 and 4 hours in machine 3, respectively, per unit. Now, why meat pie? requires 10 hours, 6 hours, 12 hours on M1, M2, and M3 respectively. And we are told that the period charge is like the fixed cost. The fixed cost is 5,000 naira. Now we are asked, formulate the linear programming model. This is a very simple question, and I will expand more than this. So, how do we formulate the linear programming model? So I'll go back to the question now. This is November 2017. So that's November 2017. November 2017. Question 5. That is what we are treating now. And the question is about this SKD Holdings. Okay, so the A part here, it says formulation of linear programming model. So let me call this A1 because I intend to stretch this A. So let's call it A1. So the first thing we'll do here, according to our model here, is we need to define our variables. What variables are we given? So we'll say define variables, define variables. So we'll say let donut be called X and meat pie be called Y, right? So we are on point. We have defined our X and Y. Now, that's the first thing. The second one is to formulate the objective function. So the first one, we've defined our variables. The next one is objective function. Objective function. It is to maximize contribution. Our contribution is C. So how do you maximize contribution? It's possible that if you want to maximize your contribution, that is your maximum C, your maximum C will be, you have to either make donuts and you have to make meat pie. You don't know how many donuts to make and how many meat pie to make, but you need to make enough meat pie and donuts to maximize your contribution. And we are told that one donut contributes 100 naira, one meat pie is 115. So this is one donut is 100. So the contribution is 100 per unit. If you make X units of donuts, it will be 100 times X. We don't know that. Then we have 115 naira per unit. So you multiply that with the number of meat pie you make. So this is your objective function. So that's it. The next thing here we said is to formulate the constraint. So how do we formulate the constraint? Formulation of constraint. So constraint. There are three constraints. We have M1, M2, and M3. Now, how are they our constraints? What do we know about them? Okay, it says here that 1 unit of donut requires 8 hours in machine M1, 10 hours in M2, 4 hours in M3. So this is 8, 10, and 4. So look at what I'm going to do. This is 8. Sorry. This is 8, 10, and 4. Donuts requires 8 hours for 1 unit in M1, 10 hours for 1 unit in M2, 4 hours for 1 unit in X3. Now, if you make X number of donuts, so it means this is going to be 8X, this is going to be 10X, and this is going to be 4X. Now, we'll do the same thing for Y, which is our meat pie. So let me put Y, Y, and Y here, and let's go and read it. What did they say it requires? 10, 6, 12. So this is 10, 6, and 12. So we don't know how many X we are producing, but one of it will require 8 hours in M1. We don't know how many Y we are producing, but one of it will require 10 hours. What is the maximum hours available? They said whose maximum available hours are 800, 600, 720. 800, 600, 720. I will come here. 800, 600, and 720. So what we mean here is this. This is the maximum available hours. What does that word mean, or that phrase mean, maximum available? It means you cannot go above 800, but you can do below 800. You can do 790, 799, 600. So it means that all these machine hours here that you'll be using to do your X and Y must not exceed 800. So how do we represent it mathematically? If it is less than 800, it will be like this, less than 800. But it's possible that it can be equal to 800. So as long as it is not above 800, it could be less than 800, it could be also equal to less than 800. So we use less than, equal to. So the same thing applies here, less than, equal to, less than, equal to. So these are their maximum available hours. Now, let me have you know that when your objective function is to maximize profit or contribution, in your constraints, you will use less than or equal to. When your objective function is to maximize your contribution, your constraint will use the sign less than or equal to. Conversely, if your objective function is to minimize cost, your constraint will be greater than or equal to. All right, well, we've seen the constraint here. The constraint is 8x plus 10y less than equal to 800, 10x plus 6y less than equals to 600, 4x plus 12y less than equals to 720. Now, if we solve this equation like this, it is possible that we can have a negative value where x may be negative or y may be negative, or perhaps both may be negative. So to ensure that we don't have any negative values, because you cannot be telling management produce minus 30x, minus 30 donuts. How? Or minus 30 or minus 50 meat pie. How? We must tell them that produce a particular positive number of x or a particular positive number of y. We can have a combination of x and y. It is possible that we may not produce x at all. And so in that case, x might be 0. Or we may not produce y at all. So in that case, y could be 0. What have we established? We have established that x and y can never be negative. That's one. Secondly, x or y could be 0. How do we present it mathematically? We'll simply say the next constraint, which is called non-negative, we'll simply say x, y must be greater than 0, or it could be equal to 0. Always, whether you are doing minimization or maximization problem, you must put this last constraint, x, y greater than or equal to 0. This ensures that you don't have a negative answer. And that's the answer to this question to formulate the model. That's the answer to that question. Formulate the linear programming model. This doesn't tell us anything. We've just formulated the model. So we will now develop something called A2. Our A2 could be to find the optimal production. Find the optimal production using the graphical method. So we have started this linear programming proper. So let's look at the stretching this thing out. So we'll say A2 finding the optimal production using graphical method. Okay. Now, if you are plotting a graph, that is, you're using the graphical method, right? It means you must be drawing a line. Now, for you to draw a line, you cannot be using greater than or equal sign or inequalities. We must convert these inequalities. So look at what we are going to do. It means here that this is your M1, and our M1 happened to be, if I remember clearly, it's 8x plus 10y. Now let's assume that we have something called a slack. That slack could be 0 or positive. So let's call this slack S1. So when we add a slack value, we are going to change this to an equal sign, equal to 800. So assuming this 8x plus 10y, assuming everything we solve here happens to be, let's say, 750, then our S1 would have been 50 to make it 800. So that S1 is the slack. What is the remaining unutilized machine hours after you have made your optimal production? That is our slack. Then you will come here, M2. If I remember clearly, this is 10x plus 6y. Now let's add a different slack for machine 2. The slack in machine 1 could not be the same slack in machine 2. But of course, this x and y are donut and meat pie. They are the same. But this slack is different for each of them. So we have S2, which is 600. Then we need to do the next one, which is this here. So we will now say this is 4x plus 12y. Add another slack, S3. We'll now turn it into 720. Now, because we have introduced slack, we now have a new constraint. Your x, your y, your S1, your S2, and your S3 must be greater or equal to 0. It must never be negative. Now that you have gotten this, we want to assume that, let's assume that all machine hours are utilized. Therefore, S1 will be 0 because you utilize the whole of the machine hours. 8x plus 10y will give you 800 because this is 0. S2 will become 0 and S3 will become 0. So at your maximum contribution, you are utilizing it in such a way that this slack are 0. You don't have anything left. No hours. You have utilized the whole possible hours. So how will that be? We will now rewrite this again to be M1 will now be 8x plus 10y. It will now be equal to 800 because your S1 is 0. Your M2 will now be 10x plus 6y will now be equal to 600 because your S2 is 0. And your M3 will now be 4x plus 12y will now be equal to 720. Now, this is a line that uses the greatest possible resource. We will now want to plot this graph by taking our table of values. Now we will be taking our table of values in such a way, normally when we want to do graph, you are told to start, let's say from minus 3 to plus 3. We're not going to be doing that because we said we don't want a negative value. So the lowest we can take is 0. And they said a line, because we are plotting a graph of a straight line, is the shortest distance between 2 points. So we're going to be taking 2 points. So look at what we are going to do now. We're going to do our table of values. Table of values. So how is it going to be? We will now say this is constraint. Constraint. We will now say this is x1. Let's call it x1. And this is y1. So it means we are plotting x and y coordinates. When we plot our x1, what is the corresponding value in y? That's it. So then we will have x2. And what is the corresponding value in y? y2. So that's the sort of thing we are going to be doing. So we will have our constraint m1, m2, and m3. Now we will start with what is the value of x when y is 0? What is the value of x when y is 0? So it means that we need to make y 0 in this case, y 0 in this case, and y 0 in this case. So we need to be finding the value of x when y is 0. Then we will come back to find the value of y when x is 0. So this is how we are going to look at it. So let's look at it now. M1, when y is 0, it means 10 times 0 is 0. So it means that 8x, okay, let's solve it step by step. Let's take them x1. Let's bring x1 to fill the table of value. So we say x1, okay, m1, sorry, m1. Our m1 happens to be 8x, 8x plus 10y equals to 800. Then you will say when y equals to 0, we will have 8x plus 10, there is a 0 here, equals to 800. So 8 times x is 8x plus 10 times 0 is 0. That's 800. So therefore, x will be equal to 800 divided by divided by 8. And that will give me 100. So that means 100 will be here. So when y is 0, x is 100. Then we will do the next one. When x is equal to 0, what do we have? 8 multiplied by 0 plus 10y will give me 800. So this is already 0 plus 10y, that gives me 800. So you will now say y will be 800 divided by 10, which gives me 80. So when x is 0, y is 80. So you have done one line. You've plotted one. So we'll do the next one and the last one. So let's plot it. Let's do the next one now. M2. Now you are looking for M2. M2 happens to be 10x plus 6y equal to 600. All right? So you say when y equals to 0, you have 10x plus 6 times 0, which is 600. This is going to be 10x plus 6 times 0 is 0, equals to 600. So 10x equal to 600. Therefore, x will be 600 divided by 10, which gives me 60. So when y is 0, x is 60. We will now go to do when x is 0. When x is equal to 0, so we know 10 multiplied by 0 plus 6 multiplied by, okay, times 6y will give you 600. 10 times 0 will give you 0 plus 6y will give you 600. And so y will be 600 divided by 6, which gives me 100. So when x is 0, y is 100. So y here is 100. We'll go to the third one, M3. So this is M3. Okay. M3 is 4x plus 12y equals to 720. Now we are saying when y is equal to 0, we have 4x plus 12, 0, which is 720. So this will be 4x plus 0, which is 720. So 4x is 720. X will be 720 divided by 4, and that will give me what? 720 divided by 4. Let's do our calculation here. 720 divided by 4, that will give me 180. So I have 180 here. So when y is 0, x is 180. So I have 180 here. Okay. Do the next one. When x is equal to 0. Of course, we have 4, 0 plus 12y 12y will give me 720. Of course, this is 0 plus 12y, which is 720. So of course your y will be 720 divided by 12. So let's do that. Somebody asked before, how do you know when it is throughput? We'll discuss throughput later. Okay, so let's go back. 720 divided by 12, that will give you 60. So when x is 0, y is 60. Now these are the things you need to plot. So you have done your table of values. The next thing is to plot the graph. So I'll come here, plot the graph. Plot the graph. Now, while I may not be using a ruler, you need a ruler in this instance. You need a ruler to help you to plot the graph. Now, how do you know your value of x and y to use? So you come here. What is the highest value of y? Highest value of y is 100. So your y-axis is 100, the highest value. The highest value of x is 180. That will enable you to know how to plot your graph. So your y is 100. So let's say this is 120, 110, 100, 90, 80, 70, 60, 50, 40. You need to be very careful that you are accurate to your ruler. 30, 20, 10, and of course this is 0. I don't have a ruler, so it may not be straight. So this is your y-axis. And your x-axis will go like this. So it's 180. So you can decide to do 2020 so that everything will enter. So this is 20, 40, 60, 80, 100. I'm looking for trouble now. 120, 140, 160, 180. So this is my x. And the trouble I was looking for, I didn't see it. This is my y. So you start plotting. M1, when x is 100, y is 0. So go and locate when x is 100. This is the x-axis. X here is 100. And of course, y is 0 here. So you mark this. So let me use a different color. So I'll mark this. When x is 100, y is 0. All right, so we'll go to the next one. So we are done with this. We are done with this. Now, when x is 0, y is 80. So go to where y is 80, and this is where your y is 80. So you will now look for how you are going to ensure that you make it straight. Wow, how do I make it straight now? I'll need to touch this here, then I'll come here and start drawing. Okay. Uh-oh, I need to be very careful. No, I need to be very careful. Let me clean all of this. Uh-oh, I've looked for trouble. The trouble I was looking for has come. Okay, so let's draw it as far as we can. So this, let's say it goes down here. It's not straight. So let's leave it up to this point. Okay, you draw and cut the x and y axis. So you label this. This is M1. If you want to put the equation, you can. But if you want to leave it at M1, you can leave it that way. Now let's look at the next one, which is M2. When x is 60, y is 0. X is 60, y is 0. Then the next one, so we've done this. And when x is 0, y is 100. Y is 100 when x is 0. Y is 100 and x is 0. So you now have to draw this, touch it. That's fine. You can label this M2. You need to be very careful. Then we'll do another one. Okay, so I'll need to tick this one off. We've done this, we've done this. So we'll now go to the next one. When x is 180, y is 0. X is 180. So you go to where you have 180. Wow, it's going to be a challenge for me here. X is 180 here. Y is 0. Then the next one, when x is 0, y is 60. So you go and look for where there is 60 and you mark. So you have to start drawing. This is not a straight line, but let's assume this is a straight line. My hand is bending. They are all straight lines. So when you have done all of that, I'll label this now to be my M3. All right, just a moment. All right, I'm back. Now, when you have done all of that, you need to identify your feasible region. Your feasible region, how do you know your feasible region? Remember, before you turn this all less than or equal to, they were all less than or equal to. So it means anyone closer to the origin is the feasible region. So it means that here, I'll need to use a different color here. This is the feasible. This is the feasible region. And the feasible region, this is 0. Let me call this one A. Let me call this B. And let me call this point C. So this point here is C. This one is A. This is 0. And this is B. So that's our feasible region. That's not all. So you can now come down and say feasible region is bound by the area 0AB, 0ABC. If you want to color it, feel free. We can decide that we want to shade our feasible region. Feel free to shade. So your feasible region is going to be all of this side. Everything here. This side is a feasible region. Feel free to shade if you feel like. So that's our feasible region. Okay. When we are done shading, we will now start the main thing. Test for optimality. You will now test for optimality. So you test the points or corner for optimality. Now, why are we testing the corners for optimality? There is a theorem called the corner point theory. The corner point theory states that optimality can be derived at the points or corners. So means that this point, this junction is a possible optimal value. This is another possible optimal value. This is another possible optimal, and this is another possible optimal. So we'll start with point 0. So we have point 0. Here, x is 0 and y is 0. Our contribution is C already. We know our contribution function from way back when we are formulating the linear programming model. We say C is 100x plus 115y. So we use that. C is 100x plus 115y. So let's replace x and y. 100 multiplied by 0, 115 multiplied by 0, that will give me 0 plus 0, which is 0. So in this case here, C is 0. This can never be our optimal contribution. We cannot be making C as 0 and call it optimal. So the next thing is to test point A. Now, what is point A? In point A, x is 0 and y is 60. X is 0 and y is 60. That's how we represent x and y in the coordinates. You put the x coordinate first, separated by comma, and you put the y coordinates. So x is 0, y is 60. You will now bring your c. This is 100x plus 115y. So let's replace it. We'll have 100 multiplied by 0 plus 115 multiplied by 60. So 100 times 0 will give you 0. 115 times 60, what would that give us? I have 60 in my calculator, multiplied by 115. That will give me 6,900. Therefore, C is equal to 6,900. Of course, this is bigger than 0. So this one is a possible optimal value. We need to test further. Let's test point B. Test point B. What is point B? In this point B, here we'll have x is 60 and y is 0. X is 60, y is 0. So this is 60, 0. It's different from point A that is 0, 60. So we'll come again. C 100x plus 115y. We'll replace now 100 multiplied by 60 plus 115 multiplied by 0. So your C here will be 100 times 60 is 6,000 plus 0. That means A has a chance bigger than B. Now, why is it big? Sorry. Now we see that A is bigger than B. Okay, sorry, you can't hear me. I got a call that disconnected my speaking phone. Sorry. Now, A is bigger than B with 900. This is because you can see here, in the case of A, we made use of a higher figure 115, which is bigger than 100. This is because Okay, so we'll now test the final part, which is C. Now, if C gives us the higher contribution, then that means C is the optimal point. So we will now say test C. Test point C. Now, we don't know the X and Y value of C. Assuming we know, if it is graph that we are plotting, if it is a real graph, C would have been something close to, let's say this is 30 and this is 50. But we can't assume. We are not using graph, and you may not be giving graph in the exam. So what do? You will, this is X and Y. So you just keep them as X and Y. And you will now do them, you will say you cannot determine. So determine X and Y using simultaneous equation. So we are going to use simultaneous equation. So what do we do? How do we use the simultaneous equation? This C is cutting across two lines. This green line, which is M2, and this blue line, which is M3. So you will say point C is the intersection of M2 and M3. So this is M2 and M3 that intersect at C. So what you do, you bring the equation for M2 and the equation for M3, and you will solve them simultaneously. All right, so let's solve M2 and M3. So we'll start, this is M2. M2 happens to be 10x plus 6y equal to 600. Let's call it equation 1. Then we have M3, which is 4x plus 12y. That gives us 720. We call it equation 2. Now, there are two methods of solving simultaneous equation. One of them is the substitution method. The other one is the elimination method. Now, the elimination method is somehow easy. All you need to do is, if you want to eliminate y, you have to make the two y, equation 1 and equation 2, to be equal. And one way to do it is by using equation 1, the value here, the coefficient here, which is 6, to multiply the whole of equation 2, and to use the coefficient 12 to multiply the whole of equation 1, such that the x and the y, the two y here will be equal. But we may not do it that way. Assuming we multiply the whole of equation 2 by 2, so we have 6 times 2 will give us 12, and we do nothing to equation 2. Okay, so look at what we'll do. We'll now say we'll multiply this one here by 2. So our M2 will now be looking like this. 2 multiplied by 10x plus 6y is equal to, you will now say 2 multiplied by 600. So anything you do to the left, you do to the right. All right, so it will now become 2 times 10 will give you 20x. 2 times 6 will give you 6y, 1200. So this here, now your M2. We'll bring our M3 the way it is. 4x plus 12y, 720. Now, how do you make this 0? How do you make this to be 0? All you need to do is just to minus the down one from the up one. So 20 minus 4 will give us 16x. 12 minus 12, 12y minus 12y will give you 0. So don't need to write the 0. 1200 minus 720. Let's activate our calculator. 1200 minus 720. Now that gives us 480. So we have our 480 here. So we can say x is equal to 480 divided by 16, which will give us what? We have 480 here divided by 16. That gives us 30. It gives us 30. So you see here, if you drew it well, your x was 30. Let's see if our y will give us 50 as predicted. So you will now need to take this value of x and use it in any of the equation to find y. So let's use it in M3. You will say M3 is 4x plus 12y is equal to 720. Now we have found x. Let's put the value of x. So this will be 4 multiplied by 30 plus 12y is 720. So 4 times 30, 4 times 3 is 12. So that will give me 120 here plus 12y. That gives me 720. Of course, 12y will be on one side to remain here. 720 will remain where it is. This 120 that has a plus here, invisible plus, will move and become minus 120. So we have 12y will give us 600. And your y will be 600 divided by 12. And let's see. 600 divided by 12, and that gives us 50 as predicted. So now we know that x is 30, y is 50. We now say test point C. X is 30, y is 50. You know, we had to do simultaneous equation to find the value of x and y. When we did test point A, we already know the value of x and y in point A. We know the value of x and y in point B. And we don't know the value of x and y in point C. Someone is saying I should go over M3 again. This was what we have, M2 here. We said it's at the intersection of M2 and M3, and these are their equations. And we said we want to eliminate y first using the elimination method. So we need to make M2 and M3 become equal in terms of y. And so the only way to make these two y's to be equal is to multiply the whole of this equation M2 by 2, which we did. And this became 20x plus 12y plus 1002. And we brought our M3 that way, the way it is. We didn't adjust it. And so we just did, how do we make y go away so that we don't have y? We cannot plus. The only thing we can do is plus or minus. We cannot plus, because if we plus, it will become 12y plus 12y will become 24y. All we need to do is minus. 12y minus 12y becomes 0. 20x minus 4x becomes 16. 1200 minus 720 becomes 480. And when we look for x, x was 30. And we said we can take any of the equation, either M2 or M3, to look for y. Both of them will give you the same thing. And we decided to take M3 because we didn't touch it. If we want to take M2, we can take the original M2 to give us the same thing. If we take the new M2 to still give us the same thing. We now took M3 and we said this is our M3 as it is. We have found x to be 30. So where we see the x, we put 30 in it. So 4x means 4 times 30. 12y remains the same. 720 is the same. Now 4 times 30 gives us 120. Your 12y remains the same. 720 remains the same. Now we want to keep all the unknowns on one side. We want to take the knowns to the other side. So this 12y is in the left hand side. That is this 12y in the left hand side, still remaining its position. 720 is on the right hand side, still remaining there on this right hand side. It is this 120 that needs to move. Let's say it wants to move from its country, let's say from Nigeria to Ghana. It needs to move from this place because this is where we have y's to stay. Then this one does not have, this is a figure. So it moves to where it should belong. There is an invisible plus here. In everything that you don't see any sign, there is an invisible plus in them. If there is a minus, you will see minus in front of it. If you cannot see anything, know there is a plus. As it is going to the other country, it is changing its currency. So it moves from minus 20, from 20 to minus 20. So your 12y is still remaining in this position. Now 720 minus 120 gives you 600. And so you look for y, your y is 50. I believe it's clear now. Somebody's asking, does it mean that if we are using graph book, we will not need to use simultaneous equation? If you use your graph book, if they give you graph book, it's fine. You may not need to use simultaneous equation, but the truth of the matter is this method, your examiner wants you to use simultaneous equation because it's a step he has to mark. It's a step he has to mark. But if you're using a graph book and you draw it well and you refer to your graph, I don't know, you may still get the whole mark. But the point here is You don't need to have a graph book necessarily to do this. Now that you've not known your x and y, we need to now test C. We said our C is 100x plus 115y. So this is going to be 100 multiplied by 30 plus 115 multiplied by 50. So what do we have? 100 times 30 will give me 3,000. 115 times 50, 115 times 50, that will give me 5,750. 5,750. When you add them together, it gives you 8,750. So when you look at 8,750, what do you have? 8,750 is the maximum. So this is the maximum contribution. Of course, it's bigger than point A, which is 6,900, which is the next maximum. So this is 8,750. So what you will now do is to recommend optimal production. You will say produce. Of course, our X is 30, right? You will now change it back to donuts because that was what was given to you. Donuts, I say X, 30 units. Meat pie, which is Y, 50 units. Then maximum contribution. Maximum contribution is 8,500, 750, right? If you want to know your maximum profit, we can even say maximum profit will be contribution minus period costs or the fixed cost. So we have 8,750 minus, the question told you your period charge is 5,000 minus 5,000, which gives you 3,750. So that's your maximum profit. This is your maximum contribution. Contribution is more important than the profit. This is what you are telling management that you want to do. So that's using the graphical method. That's using the graphical method. And that's A2. The question can say, now, what this means is that you are going to utilize your M2 and your M3 to the maximum limit. But do you see that M1, you will still have some slack, because look at M1, there is a space between here, between this line, there's a space somewhere here. And so these are the unutilized machine hours. Now the question could be, what is your slack value? What is your slack variable? Or what is your unutilized machine hour? Or let's call it what? Find your slack variable. So I'll come here and I'll say A3, A3, find the slack variable. We are going to do a test to know it, but I will show you after the test, I will show you the short way to know it. So to know the slack variable, we'll need to use the original equation we use in formulating this, sorry, coming. Yes, we need to use this. We need to use this, and we said, or we use this, fine, because this is slack variable here. Yeah? This one that has slack variable. We'll use it S1, S2, S3. So we'll test it. Test M1. M1, what is the equation for M1? M1 is 8x plus 10y. Of course, we have our S1 equal to 800. And we know that x and y, x is 30, y is 50. We don't know S1. This is 800. 3 times 8 will give me 24. That's 240. There should be a 10 times 50 here, which should give me 500. Let me make it clear. There's a 10y, which I omitted. So I will say 10, 50. So 10 times 50 is 500 plus S1, which gives me 800. So I can say my S1 will remain where it is. 800 will remain where it is. Now these two will move. This 240 has a plus. When it moves, it becomes a minus. 500 has a plus. When it moves, it becomes a minus. So your S1 gives me, let's calculate now. We have 800 minus 240 minus 500. That is 60. So S1 is 60 hours. So slack is 60. Now, you may even stop here, because if you look at optimal, the one that gave us the optimal production is at the intersection of M2 and M3. So it means that M2 and M3 giving us the optimal will never have a slack value. Their slack would always be 0. But M1, which did not join the equation, will always have a slack value. We can test it and see. So we say test M2, and our M2 happens to be 10x plus 6y now plus S2 will give us 600. Okay, so what do? X is 30, Y is 50. So this is 10 times 30 plus 6 times 50 plus S2, that's 600. 10 times 30, that gives me 300. 5 times 6 is 30, that's 300. Plus S2. So S2 remain where it is. 600 remain where it is. 300 as plus, it goes here, it becomes minus. The same thing with the other 300. So that gives you 0. No slack. We test M3. Test M3. Our M3 here was 4x plus 12y plus S3. That gives us 720. Of course, x is 30. 4 times 30. Y is 50 plus S3, that's 720. 4 times 3 is 12, that's 120. 12 times 5 is 60, that's 600 plus S3, that's 720. So what happened here? S3 will remain its position. 720 remains its position. This will be minus 120 minus 600. That will give you 0. So you say slack only occur in machine 1, machine M1, and it has 60 unutilized hours after production or optimal production. So that's how you look for the slack. You look for the slack variable in the particular machine hour that did not go into the simultaneous equation. So that's the only one that will give you the slack variable. So now that we've done the slack variable, you can be told to look for the shadow cost. You can be asked to look for the shadow cost or the shadow price. So let's say this is A4. A4 A4 is to find the shadow cost of M2 and M3. Now, you only find shadow cost on those machine hours that gave you the optimal value, never on M1, because M1 has slack variable. Now, what is the theory of this shadow cost? Shadow cost is saying here that assuming you have the power or the ability to increase your machine hour by just 1 hour, what will it cost you? Or how much contribution will you earn? That is called shadow price. If you can increase the second machine, keeping the first one constant, by just 1 hour, which of these is it possible that you can achieve a higher contribution if we are to increase by just 1 hour? So it makes sense not to do it on M1 because we have already 60 unutilized hours. No need increasing it because we have unutilized hours. But in M2 and M3, there is no slack. So if we have the power to increase by just 1, what would that be? So what we will do now is we'll look for the shadow cost or the shadow price for M1, for M2. Find shadow price of M2. Now say by adding 1 hour. So we'll go back and do a simultaneous equation again. We'll start, this is M2. What's our M2 here now? Our M2 is 10x plus 6y, which gives us 600. Now, because we are adding 1 to M2, we'll just say plus 1. Then our M3 will remain the way it is, 4x plus 12y. That will give us 720. So this is equation 1. This is equation 2. Like we did before, we are multiplying this by 2. So now this will become 2 times 10 will give you 20x. 2 times 6 will give you 12y. 601 times 2 will give you 1202. Then this other one will remain the same. 4x plus 12y gives me 720. Now I will still minus. This will still give me 16x. This will become 0. But now, what will this give me? It will now have an addition of 2. 1202 minus 720. That gives me 482. We had 480 before, but now this is 482. So our x will now give me 482 divided by 16. In this one, you are free to keep your answer in decimal. Now divided by 16, we'll write it the way it is, 30.125. 30.125. You know, when we did the first one, we had 30 exactly. But now this is 30.125. Now, we'll use this value of x. Let's use it in this equation that doesn't have 1. We have 4x plus 12y, which is 720. Our x already is 4 times 30.125 plus 12y will give me 720. So let's multiply 30.125. Let's multiply it by 4. We multiply by 4. That gives me 120.5. 120.5. So this is 120.5 plus 12y. That gives me 720. So what do? 12y retains its position, 720 retains its position, and this goes over, it becomes 1 minus 120.5. So we have 12y gives us, put the minus here, 720 minus 120.5 will give me 599.5. Before it was 600, now it's 599.5. 599.5. Therefore, y will give me 599.5 divided by 12. What would that give me? Now let's divide this by 12. Wow. We have 49.96. Okay, that time we did 3 decimal. So 49.958. 49.958. So we can say 49.958. All right. So it means that we have x equals to 30.125, y equals to 49.958. So what do we do? New contribution, I will call it CM2. I'll call it CM2 because we are testing shadow price of M2. Now it will give me 100x plus 115y, right? Now we have 100, x is 30.125 plus 115, 49.958. So what will this give me? This will give me 3012.5. Let's test it. 100 multiplied by 30.125, 3012.5 plus, let's test the other one. I have this in my calculator already, multiplied by 115. That will give me, I'll make it to one decimal place too, 5745.2. 5745.2. 5745.2. When you add them together, let me add this 5745.2. Is it 0.2? Let me see the other calculator. Yes, it's 0.2. That will give me 8757.7. 8757.7. 8757.7. I'll need to, this is 0.2 here. So this is your new contribution. So this is your new contribution. I call it CM2. Then I will say original contribution, C optimal. I'll call it C optimal. What is our C optimal we got before? 8,750. So this is 8,750. So when you find the difference, so your shadow price is the difference. That will give me 7 naira 70 kobo. 7 naira 70 kobo. So it means that if you are to increase M2 by just 1 hour, you are going to get a contribution increase in by 7 naira 70 kobo. So it means that what it means is that 1 unit of M1 in this instance will give you 1 hour of M2, 1 hour of M2 utilizing this production will give you 7 naira 70 kobo. Now, let's look at the second one to test M3. So I will say test M3 by adding 1 hour. So you bring the equation back, you bring the equation. So we'll say M2 will be 8x plus 10y equal to, what am I doing? Is that what I did? No. M2 is 10x plus 6y equal to 600. Now your M3 is 4x plus 12y is equal to 720 plus the extra one. So you see how you are interchanging. If you are testing, you cannot test the two at the same time. You cannot add one here and one. You must test them one at a time. And we did again like this. So you see why your lecturer will want you to use simultaneous equation. Sometimes if you have a graph in that optimal, you can use it no problem if you can do it well. But your lecturer wants to know how you can do your simultaneous equation. So you can multiply this by 2 as we did before. So we have 2 times 10 gives us 20x. 2 times 6 gives us 12x. And this gives us 1,200. Then this will remain the way it is now, 4x plus 12y, but now this will be 721. Simply minus, this will give me 16x. This will go off, and now, what would this give? 1, 2 minus, so sorry, 1, 2 minus 721. Remember, it gave us 480 before, but this is now 479. 479. Now your x will be 479 divided by 16. So your 479 divided by 16 will give us 29.9375. 29.9375. 29.9375. 9375. So that's your x. Now we'll use this value on x. Let's try it on this equation 1. We can as well try it on equation 2. So desire, we have 10x plus 6y that gave us 600, right? So let's try it. This is 10 multiplied by 29.9375 plus 6y gives me 600. So this gives me like 299.375 plus 6y, that gives me 600. Your y remains, its 6y remains where it is. So this is 6y equal to 600 remain where it was, 299.375. So your 6y gives you what? Okay, so I'll remove this from 600. That gives me 300.625. 300.625. 300.625. Therefore, y will be 300.625 divided by 6. So y will eventually give us what? So divided by 6 to give me 50 point, let me make it 4 decimal, 50.1042. 50.1042. 50.1042. Okay. All right. So that's your fifth. That's your okay. Uh-oh. Sorry. I don't know how this came. So now your y is, let me see, this thing is not going. Your y is this. So now what happened? You will now say new contribution. I'll call it CM3. We said it is 100x plus 115y. So this is going to give me 100. X is, we said our x was what? 29.9375. Then your y is what? 50.1042. So let's look at it. Multiply by 100, the decimal will move 2 places to become 2993.75. Let's multiply this one also now. I have this on my calculator. Multiply by 115. I have 5761. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. 5761.98. All right, so when we add these together, what do we have? Two 993.75 plus 5761.98. That gives us 8755.73. 8755.73. 8755.73. So this is your new contribution, CM3. Original contribution, 8750. Remember, this was 8750. I will now say shadow price, which is the difference, is going to give us 5.73. Now compare 5.73. Let me bring this to calculator. Compare 5.73. Compare 5.73 with 7.7. Which one is higher? 5.73 versus 7.70. It shows that M2 aims more contribution than M3. So if you have any means, to increase your capacity of your machine hour, you will favor M2. You will want to make sure that M2 is working. If anyone should be giving more attention, should be M2, because per hour you are earning more contribution than M3. That's your shadow price. That's your shadow price. Now, I have stretched that question so much. The B part says here, discuss briefly the uses of linear programming in performance management and indicate whether there are any limitations in this kind of model. Let's see the answer. Usefulness of linear programming model. 1. It is used to solve limiting factor decision when there are at least two limiting factors. Another usefulness is it can be used to calculate shadow price of a limiting factor. I have shown us how to calculate the shadow price. 3. It can be used to determine additional units of the limiting factor, which can give extra contribution. It's still going to tell us the shadow price. 4. It helps management to identify slack that might be used by management to identify the amount of constraint that is not used in the optimal solution. In our question, the M1 was the slack. We have slack of 60 that was not used in the production. And 5, it is used in solving operational problems. Now, if you are using this kind of operational problem, kind of solution to solve operational problem, you have to use your ERP, your tools here, or your Excel. I told you how to use it in Excel. you have this solver. Solver. I think I should open Excel for you to see where you can use the linear programming problems. Okay. Now, limitation. One, it cannot be used to solve limiting factor when there is a single limiting factor. We said it's only used when there are more than one limiting factor. So you cannot use it in one. When there is only one limiting factor, we've learned limiting factor solution. That is what is best suited for it. Two, uncertainty is not taken care of. Three, parameters are assumed to be consistent. So we assume that the parameters do not change, they are consistent. Four, it is only useful when solving allocation problems involving more than one limiting factor. Five, for non-financial managers, it could be complex. I also know that for you students, it's also complex. Six, it assumes linearity. So there's a linear relationship. But sometimes in practice, linear relationship may not hold because there may be a discount in raw material that will change the whole equation. Also, there may be a learning curve. You know, your learning curve, when it's a curve, it's no longer a straight line. So you have a learning curve that is curving, not a straight line, it's curving, and at a point it goes straight. And it is that straight line is in parallel to the x-axis. All right, number 7, it assumes divisibility of products. That means fraction of products cannot be produced. What it means here is we said x is 30, y is 50. You cannot produce 30.1 or 30.5, 50.5. No, it must be whole numbers. That is what it assumes. And it assumes that maximization of profit is the objective of organization. But in practice, organization may have other objectives, such as reduction of costs, provision of services, irrespective of whether there's profit or loss. That could be organizational objective. It could be gaining market share, even if they make loss, they make market share. So not only profit should be assumed in real life, but in this model, we assume that it is profit that is the objective function. Okay, so we have learned the techniques for limiting factor. So what have we learned here? Let's summarize our answers here. What we have learned so far from this question. What is the summary takeaway? Summary of solution. 1, graphical method was used. 2, table of values found using 2 points, i.e., when x equals to 0 and when y equals to 0. 3, one of the constraint does not enter into the optimal solution. Thus, it has a constraint, sorry, not constraint, a slack. It has a slack. It has a slack of 60 hours. That is M1 equals to 60. Okay, I will say, is it M1 I will use? I will say it's not M1 I will use. That is S1 equals to 60. All right. Then 4, optimal solution was gotten when we tested the points in the feasible region. In the feasible region. And M2 and M3 gave us the solution using simultaneous equation. Then 5, shadow price is gotten after optimality is obtained. We test each of the lines or the constraints M2 and M3. We test each of the constraints M2 and M3 in turns by adding 1, let's say plus 1, to the total value. To the total value. 6, the shadow price that gives the highest contribution per extra scarce resource should be most concentrated on. concentrated on. So these are the takeaways we've gotten from this one question which we solved. So I would like you to go again and solve, look at these questions. In our next class, we'll be continuing with the same board. We will be looking at stretching this question again by saying C. We'll be doing a C. Use simplex method to find optimality and slack variables. So I will now teach you how to use the simplex method to get to the optimal solution and to get the slack immediately. So in our next class, we'll be looking at C, using simplex method to find optimality and slack variables. So come prepared for the simplex class in the next class. It promises to be very, very rich. Meanwhile, I'll be sending you this note, although we are not going to we're not going to solve anything here. It's just for you to practice on your own, to see how all of this is being done and use it to also amplify your knowledge. So everything here contains the same notes, the same things I've just done. I said before, we are not going to solve any of these. This is for your further learning. And when we come to simplex, we'll use this again to learn how the simplex method can be used in getting optimality. So this is just going to serve as your notes, but we are going to use the same question that we have used tonight to solve the simplex question in the next class to see whether we will get the same answers as we got in the graphical method. So if you have any question at this point, feel free to ask me privately in the WhatsApp or in the email. So thank you so much once again for coming to today's class, and I believe it's enjoyable. Your learning curve is getting, you are getting to the steady state. I believe that. So once again, my heartfelt appreciation to all of you today. So see you in the next class when we'll have an enjoyable time together.